We'll start this video with the question: if there are 23 people in a room, what is the probability that at least 2 people within this room will share a birthday? It seems natural to think this probability will be quite low. However, the answer is 50%. This is the birthday paradox. In fact, the birthday paradox isn't actually a paradox after all, just counterintuitive. Often when thinking about the problem, we only think of the likelihood of somebody else in a room of 23 people having the same birthday as ourselves. We fail to notice the many other possible combinations of people which may have the same birthday without us being involved. When calculating the probability, it might appear sensible to count all of the pairs and find all of the ways which they can match. However, this can prove to be quite difficult, as there may be more than one pair who match birthdays. Instead, we can change the problem around and calculate the probability of everybody in a room full of 23 people having separate birthdays. Then, we can subtract our result from 1 to reach the answer to our original question, as the probability that there's a match equals 1 minus the probability that there's not a match. Now, imagine that each of our people enter the room one by one. The first person definitely has a unique birthday, so has probability 1. The second has a 1 minus 1 over 365 probability of having a separate birthday, as 1 has already been taken out of 365 possibilities. The third has a 1 minus 2 over 365 probability, as 2 have already been taken, and so on, all the way up to the 23rd person, who has a probability of 1 minus 22 over 365. So overall, the probability that there's not a match equals 1 times 1 minus 1 over 365 times 1 minus 2 over 365 all the way up to 1 minus 22 over 365. This gives a result of around 0.4927. So if we substitute this into our original equation, the probability that there's a match equals 1 minus 0.4927, which is 0.5073. So there is a 50.73% chance that at least 2 people in our room of 23 people will match a birthday. We can also use this method to calculate that the probability of at least 2 people within a room of 75 people sharing a birthday is 99.9%.